Okay, so when you open up Excel, you should see this form on the way, and I'll show you how we do that. And when you click, you're going to have you're going to make your form look like the one on the paper. And then over here on the right, there's an example of the form again. So when you click that, it says you need to provide the data to do this. Okay, now I'm going to close the form. And now what I put in here is a little thing that says, do you want to exit Excel completely? In other words, do I want to close down Excel, or do I just want to go back to Excel? So I'm going to say, no, I don't want to close it down completely. And that'll just put me back in the Excel spreadsheet. Okay? So be careful that you read the question. The data on here in the X, Y, X prime, and X and Y double prime columns, that's not the data that corresponds to the drawing and all that. It's just some data. Okay, so don't try to compare that to this and all that kind of stuff. They don't necessarily correspond. Okay? So over here, I'm showing you what your form should look like, and then what your graph should look like, some kind of a graph like that. Okay, so if we go over to custom ribbon, that's oh, this is my computer, that's why. Okay, so if we go over to developer, there's a couple things to look at in here. One is under this workbook. Okay, this workbook is run every time this workbook underscore open. So that's an open event of this workbook. Well, that's run every time you start Excel. Okay, every time you start open this Excel file, it's going to run the code that's in this workbook underscore open. And in that subroutine there, it says load derivative calculations and derivative calculations.show. That's why the form pops up on the screen immediately. Okay? Now, if you want, everyone very carefully, and don't jump ahead, very carefully go ahead, delete the comment line. That's there. Okay. Go back, do a save. Okay. Okay. Has everyone got it? Okay. Go ahead and close this. Close Excel. Okay. Now come down and open Excel, the template. And you see what you get now, the difference? There's no Excel in the background. It's just the form itself. Excel is running, you just can't see it. Okay? Now what you want to do is go ahead and let's close this form. And when you say, do you want to leave Excel completely, say no. And what it does, it turns the Excel back on to show it to you. Okay? So that way you could write, or you could just have left and never shown Excel at all. Okay? So you can actually write Excel programs that don't actually show the Excel grid spreadsheet if you want. Okay? So if we look at how to do that, okay, so there's this workbook. What I'm going to do is I'm going to come back in here now for this application, .visible. I'm going to comment that line out again. Okay? That way it'll just keep Excel showing. I don't need to be hiding it while I'm doing my development. Okay, if I go up to the sheet 1 and take a look at that, that's the exact same thing that was in this workbook. Because this workbook is only run the first time the Excel is loaded. It doesn't run all the time. So if I want to run the program again from just, I'm going along and I want to run the form and do some stuff, I need to have a button that does that. So when I click this button that's on the spreadsheet, the button there, compute and plot first and second derivative, when I click that button, this code runs, and it can hide Excel also if you wanted to. Okay? And then load the spreadsheet, load the form and show it. Okay, let's go down here for a minute. Let's look in the module. Okay, in the module, this is where you're going to put your first derivative function, and then you're going to put your second derivative function in here. For this one, you're going to need to do some interpolation, because what you're going to do is the user is going to give you an x value, and you're going to give them the value of the closest data point to his x value, and then you're going to interpolate the data for that x value. Okay, so maybe you're plotting up the sine from 0 to 2 pi, and the user's going to say, I want the value at, you know, 0.37 radians. Okay, so you're going to calculate the value of the function at 0.37 radians, and then you're going to calculate the closest value in your data points to 0.37 radian or 0.37 radians, whatever. And then you're going to calculate the derivative there, right? So you're going to interpolate to get your derivatives and things like that, and you're also going to look at what the closest data point is. So that'll show you whether you get any benefit out of interpolating as opposed to just getting the closest data point. Okay? So you're going to need your my 1D interpolation so you can interpolate, but you've already written that, so it's just a matter of bring that code over and put it in here. And you'll need your find bin function to go along with your interpolation routine. And here's our evaluate user equation. That's the same one we had in our least squares fit program. Okay, this is the same function here. Okay, so it's really worthwhile as you do functions, as you make them, do your best job. Put the documentation in it, put a lot of comments, make it as good as you can, because then you can use it over and over in later programs and you don't have to start from scratch again. If you do a really poor job, you're going to pull it up and then you're going to have to figure out what you were doing in there if you don't have comments and things like that. Okay, so there's your first, second derivative, your interpolation. Now let's go to derivative calculations form. So within the forms, there's two forms. The first one is where we're going to just do the plot that comes out. Okay, and in this one I got rid of the picture box, image 1, the picture box, or I think we might have called it chart before. Just got rid of that because you can plot your picture right to the form. And that way you don't have to worry about trying to make your picture box fit the form. It'll fit it exactly. Use your little stretch parameter in there to make it fill the form. Okay. Now derivatives calculation, if we double click that, okay, there's the form that came up when we first started up the program. Okay, so it's just a form that exists. It has one button on it right now. And then you're going to add all these other labels and edit boxes and things like that to this form so that it looks like this. So the user has somewhere to input his data. Okay, now if you look on there where it says, it has a little box that says input data, and then one that says results using closest data point, and then results using interpolation. So those two results those are output values.
Is that like what we use the frame button, don't we?
Yeah, so when you look at your toolbox, see this one right here where it says XYZ? That's the one that says input data. Okay, then you can bring your labels and your edit boxes and things like that within that frame. Okay? So it just sort of lets you divide your form up and collect things a little better. Okay, so you're going to build that up. Now let's look at the code that goes with this. Well, one way to do that, where it says derivative calculations, just go ahead and right click and say view code. Okay, so this looks exactly like the code we had when we were working on spreadsheets, right? I mean, there's no difference. This just happens to be a form instead of a spreadsheet. Okay, so here's a private sub calc and plot. So that's the code that executes when I hit that button that's on the form. Okay, and right now all it says is you need to provide the code to generate the data and plots. Okay? And then it says Userform Initialize. Now this is something you can do if you want. You don't have to do this, but it's sure going to make your life easier. And the idea here is when the form pops up, you can use this Userform Initialize to fill in all the edit boxes with your test data while you're debugging. That way you don't have to keep going back and filling in the data, run it, get something not work, change the code, run it again, get the form show up, fill in all the data, run it, it doesn't work. You know, that can get real old real fast. Okay? So one way around it is to use this Userform Initialize. So how did I get there? You come up here where it says General and go down to Userform. See, there's a calculate and plot, frame 1, label 1, text box 1. Those are the three things we just dragged onto the form. So everything that's on the form will be, every control will be listed here. And so there's our user form, that's a control. So I'm going to click it. And then over on the right, these are all the things that the user form can respond to. These are called events. Okay? So Excel's an object-oriented language, and all the different pieces of Excel, forms and edit boxes and things like that, they all know what to do to process data related to them. Okay? So you can come in here and say if the user clicks the form or if he double clicks it, what we did, we've got the initialize. You can do something when they press the key down, or you can do something when the key comes up if you're clicking. Okay, things like that. Or there's the mouse down and mouse up. Key down and key up must be actual keys on the keyboard. Okay, you can remove the control, resize it. Okay, lots of things that so you see that the initialize and the terminate are bold, meaning that we've already added that code. Okay, but that's how I added it. Just go in there, identify user form, go down, pick the initialize event. So now when the form is loaded, this code's going to be run. Okay? Now what this code does, if you look down here, all that writing just telling you what it does. But basically here's pi, and down here I have EBX user equation dot text, x colon sign x, EBX lower bound dot text, EBX upper bound dot text. So those are the names of the edit boxes that are on the form when I did mine. Okay? What you need to do is either use those same edit box names or use your own names, whatever you want to put in there, but just change these so that they match your edit boxes. And what will happen is this will fill in the form for you when the form is located, when it's loaded. Okay? That way you'll have all your data in there and you can just debug and not have to worry about entering the data all the time. Okay, so if we look down here, we have a user form terminate. So this is code that's executed when you click the little red button up there, the red X. Okay, do you want to exit Excel completely, yes or no? Okay, if you said yes, that ends up being a 6. Therefore, application.visible is true, and then application quit. So application quit means stop Excel. Basically kill the Excel program. Okay? If you said no, then it's going to say application visible is equal to true, and that'll just make sure that Excel is showing, and then it'll get rid of the exit the form. Remember, when you hit that red button, you're exiting the form, not Excel, just the form. Okay? Yeah.
How'd you find out if the X or the exit was 6 and 7, or what they corresponded to? Did you just do that?
You have to just try it. Hit yes, and then put it into break mode, and then put your mouse over response and see what it says.
Okay.
Okay? There's numbers, I think there's like 0 through, 10 or something. Depending on different, did you click yes, did you click no, did you click cancel, did you click whatever. There's lots of different things you could click, depending on what you put in your message box.
Okay.
And so each one of them just has a number.
Okay.
And so you have to just figure it out. Yeah.
Can you show us how to put the plot straight to the form instead of the image? Because I think the only one we know how to do is the plotting to the image.
Well, you should have the question was about how do you get the plot to the form instead. If you look in your subroutine or your function, whichever it was, that does your plotting, okay, there should be a line in there that says my chart. I think that's what we called the form. It says my chart dot chart or my form dot image 1, depending on whether you change the name, dot picture equals, and then we had the name of the picture. Okay. What you would do is you would just say my form or chart form dot picture equals. So, because image 1 is a control on the form. So it's form dot picture control dot picture. So if you want to put it on the form itself, just go form dot picture. So you just have to take out that image out of there and it'll work.
Then we no longer have to put an image box.
Right, then you don't need an image box on there.
Got it.
It just makes it easier because then it automatically fills the form without you having to fiddle around with the image box to do that. Okay, so any questions? That's sort of goes over all the things that are already in here. Okay? So let's go back now and look at let's look at what we need to do. Okay, so looking at this, what we have is you're going to read in the equation, stick that in a string. I got some variables up there already, so user equation, stick that in there. Read in your lower bound, your upper bound, your number of data points, and your location for the computation of the derivative. So those are all inputs by the user. And then you're going to output the data point that's closest. And you need to think about how to get the data point that's closest to you when you give a value. Okay? So you're going to need to look at the data and then figure out how to get to the closest data point, not just the one to the right or to the left of it, but the closest one. Okay? So that's something that comes up a lot of times. So you just play with that for a while. Put in 5 data points so that it's easy, and then pick out X's so you know where it should go until you get it going to the right place. There's no reason to work with, when you're debugging, there's no reason to work with more than like 11 data points. That's plenty to debug everything. And once you get everything working, then you can go. And so one of the things we'll be looking for when you grade it is, did you go to the closest data point, or did you just go to a data point that's somewhere near the thing? Okay, you want to actually go to the closest one. And then you want to use your interpolation to get the y, the first and the second derivative at that location itself. Okay, so you'll have the x, the y, the x1, and the x2 by this point, right? And so you're going to pass in x and y when you want to find what interpolate for the y value. Pass in x and y1 for the first derivative interpolation, and x and y2 for the second derivative interpolation, right? So the interpolation routine doesn't know what it's being given. You're just going to pass it either xy, xy1, or xy2. Okay, so let's go ahead and see if we can come up with the algorithm that we need to get all this done. Okay, so what do we want to do? We want to, let's get the input for the program, right? Okay, so what's the first thing we can get? If you look at your little piece of paper, so why don't we read in the equation, right? Okay, so once we got that, get the upper and lower bounds. Get the number of data points. Okay, this is why it's really your first step in writing a program a lot of times is to get out a piece of paper, draw what you think you want your spreadsheet or your form or whatever to look like, and sort of think about how you want the data organized, because if you can do that, that'll make organizing your code a lot easier, because you can just look at your form and then write your code from there. Okay, and then we need to get the computation point. Okay, what's the next thing now? Okay, who knows? Huh?
Check the computational point in the bounds.
Okay, so what I mean by that is the x value at which you want to compute the derivative. Was that your question? Or so it's that in the little handout, it's 0.785, that number there. Okay, so now what's the next thing you need to be doing? Huh? Okay, get the x values. Okay, can I get the x values yet? What do I need before I get the x values?
X increments.
Okay, I need to compute the x increment, right? Okay, so now I can calculate the x values, right? The x and y values. So this is I'm gonna indent this because this is gonna use, let's say, with a for loop, right? Okay, so how am I going to do that? I'm in a loop now from 1 to n data, right? So what would be my steps to get the x and y values? Okay, well, call the equation function, okay, with what?
The x values.
Okay, call equation function with the x values, right? So what do I need? What do I need to do before I call the function then?
I loop.
So I need to calculate the x value, right? I need to calculate I loop. Right? I've got the starting point, I've got the x increment, so I can basically take starting plus x increment times I loop minus 1, right? So I need to, so my first step in here is going to be to compute x I loop. Okay? Once I've got x of I loop, now I can call the function of the evaluation function to compute y I loop.
Call function, evaluation function?
Yeah? It's a function, and it evaluates a function. And the output of it is going to be y of I loop. Okay, what do we want to do here? We want to check to see if there was an error, right? You're going to be doing error checking. I do Control S to save, just to make sure you don't lose anything. Okay, now we can go back up to the top, right? And we've got an x of I loop and a y of I loop. Now I can go back up to the top of the loop, move to x at I loop plus 1, y of I loop plus 1. I can go all the way through. So basically, I'm done with that loop. So what's the next thing I need to do? Let's get this written out to the spreadsheet, right? So what do I want to do? How about locating the start on the spreadsheet for the output, right?
But yeah, have you already defined those?
Yeah, it's already constant.
Okay, I mean they're okay, so they're located. So now what do we need to do? We need to actually write x and y out to the spreadsheet. Right? We can use a for loop for that. So remember now, when you get to these, what you have is you're going to have I loop going from 1 to n data, and you probably want a variable called current row, right? Going from the start row to the last one, right? You've got two different things to keep track of. One is where you are in the array, and the other one is where you are on the spreadsheet. Okay, so let's say that's not a very big loop. Let's say we got done with that. What's the next thing we're going to need to do? Okay, do I want to plot yet? Okay, so let's call our function to calculate the first derivative. We'll call that y1. And so once we get back from that, we should check for errors. And,
You may want to lift the screen.
okay. Okay, now that we've got the first derivative, we can call the second derivative, right?
You put it on the.
Yeah, okay. Okay. Then again, check for errors. Do a Control S to save. Okay, what's next? Yeah.
Do we have to figure out what the closest data point is before we can calculate the derivatives?
Well, not yet. Well, we're gonna. So the question was, don't we have to calculate what the closest data point is? Well, first thing we're going to do is we're going to calculate the first and second derivative as all the data points and get that done first. Then we'll go into calculating the derivative at the closest data point and then the derivative at the interpolated point as our last two things. Okay, so check for errors. Now we've got the second derivative. Okay, so now we've got the first, we got x, y, y1, and y2. So what we're going to need to do is if we want to plot up y1 and y2 like it shows in the picture, we need to write y1 and y2 to the spreadsheet, right? So that they can be plotted. Okay, so now you've got that done. Now you can start looking to find the closest point, right? Okay, have we read in that data point yet? Yeah, we already read in up at the top that x value, right? Get the computation x value. Okay, so what we're going to want to do now is determine the closest data point. Anyone have any ideas on what the closest data point's going to be? Yeah.
We could subtract, basically find the absolute value difference between the one on the left and the one on the right, and then pick the one that's lower.
Okay, I could, but so I need to, if I'm going to do that, what do I need to do?
We'll pick the values for those points.
Well, I need to figure out which data points it's between,
Right.
right? So I have to find out which bin it's in. That's one possibility. Okay. What's an easy way to figure out what bin something's in? We could use our find bin function. That would work. What's another way? Anyone got another idea? How about if my bins are, let's say my bins are 10 wide, 10 units wide. And I know that already because I know what x increment is, right? And let's say it starts at some number and the location I'm looking for is 57 units to the right of the start. Okay, So I'm 57 units into the function from the left side. How can I figure out what data points are to the left and right of it? Right, so we're starting here. Call it 0, 1, 2, 3, 4. Well, this would be 0, 10, 20, 30, 40, 50, 60, 70. And I'm here at 57. Right? So I want to, what's the way I can figure out which bin I'm in? Yeah.
Divide by 10 and drop the remainder.
Okay. Well, if I do a divide by x increment, right? It's not always going to be 10, whatever x increment is, right? If I divide my number, the distance between my number and the beginning point, if I take that distance divided by x increment, then this is going to be 5.7 in this case, right? So if that point part, if the 0.7 ends up being greater than 0.5, then I'm going to go to the next one up. And if it's less than 0.5, I'm going to go to the one down. That's one way I could figure out which one it is. Right, so, and this is going to be, so this is data point 1, data point 2, data point 3.
Should we write this, should we copy this down, or
No, you just, well, if you want, you can write it down.
is it necessary?
It depends on what you can remember. This is only one way. There's lots of ways to figure this out. Okay? You guys are coming up with one way here. Okay? So, if this is the first data point, this is the first bin, right? So there's 5 bins to the left, or 6 data points to the left. So, if we end up with 5.7, that means I'm between data point 6 and data point 7. It's off by 1. So just be careful with that. Okay, and then if it's 0.5 or greater, then I would go up, and if it's less than 0.5, go to the left. Okay, so you can, that's not the only way to do it. One thing, you could use your find bin function, right? And that would also give you a data point. That would give you the one to the right, and then you have to figure out which one's closer. So there's very rarely one way to do something. Okay. So this will allow me to locate. In this particular case, what I'd want to do is I'd want to locate data point number 7. That's the closest one to my particular my user selected point in this particular example. So what I want then to go on the spreadsheet, on your form, is I want X at location 7, Y at location 7, Y prime, and Y double prime at location 7. That's the closest data point. Okay? And then for the other one, what you can do is you can pass X and Y into your 1D interpolation, and it'll pass you out the Y int that corresponds to that. Okay? So when I'm just looking for the closest data point, I don't need to go in and do the whole interpolation routine. I just need to go find the closest one. So that's sort of a subset. Remember what I talked about earlier about when you want to find the maximum in an array of numbers? That doesn't mean sort it and take the first number in the sort, because that's overkill. That's a lot more work than you need to do. So same thing here. We don't necessarily need to go in and use the interpolation type thing to find out the closest data point. We can just do it with some divisions, and it's just a matter of keeping track of where the data points. Now, once you get this worked out, this is where I suggest you put in like 11 data points and then test it and try, make your data points 0 through 10. So that'd be 11 data points, and then you can try putting in, 5.5, 5.51, 5.6, 5.49, and see if it goes to the right locations and stuff like that. Okay, so that's determine the closest data point, and once you've done that, what do you want? You want to write so X Y Y1 and Y2 to the form. Okay, and when you're done with that, now you want to use your interpolation routine. To compute the value of Y, Y1, and Y2 at X int and write to form. Okay, once you're done with all that, you've pretty much finished the program.
So we're not done with the pseudocode for this part of it?
That's it. You're all done. I think that does everything you need to do for this, right? Okay, so what I would do is I would start off and just work this part first, and don't worry about calling your interpolation routines right now. Okay, I mean your derivative functions right now. Get your data read in, write your stuff to the spreadsheet, find your closest data point, plot up the XY values. You can do all of that before you even start to worry about the first derivative, the second derivative, or the interpolation. Right? This is just the main driver of the program. So work on all that first. Once you're happy with all of this, then you can go in and actually start putting in the functions to do the derivatives and stuff like that. That'd be your quickest way, because it doesn't make any difference if you have the derivative functions working correctly if this isn't working, right? So you might as well focus on this first and not get distracted by the derivatives and stuff. Okay? And you saw those derivative functions, I mean, they're just not there's not a whole lot to them once you get all the definitions of the derivatives down. They're actually fairly short. And your interpolation one is fairly short, right? Now, I'd suggest maybe you go ahead and try to just write your interpolation one from scratch, and then go back and refer to your saved function if you get stuck, as opposed to just blindly copying it and sticking it in, especially because interpolation could be on the test coming up, right? So it wouldn't hurt to be able to review that. Okay, any other questions? So you can go ahead and get started. We got a half hour to.
The private sub user form terminate, is that already completed, or?
Yeah, that one's already all done. You don't really need to do anything new there.
But we still need to finish the user form initialize.
Yeah, well, you need to either use the same names I used, which you can or cannot, it doesn't matter to me. But if you use different names, be sure to update the names of the edit boxes in there so it writes it in. It just, after you fill out the form once or twice, you'll go in and fix that so you don't have to do it every time you debug. It just gets real old typing the same thing in over and over. Yeah, let me stop this thing.